One of the most charming cosmic phenomena is the possible supernova of Betelgeuse. Situated in the shoulder of the star grouping Orion, Betelgeuse is a red supergiant nearing the conclusion of its life cycle. Abruptly, in 2019, one of the most luminous stars in the heavens began to dim noticeably, being discernible even to the unaided eye. For several months, its radiance faded to such an extent that numerous watchers speculated whether the star was perishing. Aiming their telescopes at the large star, researchers were surprised by evidence of the massive dimming. Betelgeuse is thought to be on the verge of erupting into a supernova, signaling the conclusion of its stellar life. But when and why will this cosmic detonation transpire? Could it pose catastrophic effects for our planet? The radiant scarlet star Betelgeuse is located on the upper right shoulder of Orion the Hunter. You might recognize it by its alternate name, Alpha Orionis, although it is the second most luminous star in that constellation, following the fantastic supergiant Rigel. It continues to intrigue scientists because of its fluctuating behavior and distinct moniker. Alpha stars are generally the brightest within their constellations. And although Rigel surpasses it in brightness, Betelgeuse draws attention due to its sizable mass and reddish hue. Betelgeuse, also known as Alpha Orionis, ranks among the most renowned stars in the night sky, being the 10th most luminous and 7th most visible for much of North America, Europe, and Canada. Its designation is derived from Arabic and indicates the armpit of the giant, referencing its spot in the star grouping. Betelgeuse sheds approximately 1 solar mass every 10,000 years, releasing materials uniformly in all directions and producing a nebula surrounding it. This nebula spans 30 astronomical units, or 30 times the stretch between Earth and the Sun, and is 250 times more massive than the star itself. At its heart, Betelgeuse's hydrogen nuclei merge under immense gravitational stress, creating helium and emitting radiation and heat in the act. As the star depletes its hydrogen, it begins fusing helium and carbon as substitutes. When helium runs out, neon combines with carbon to yield iron. The merging of iron fails to produce energy, leading the star to collapse under its own gravity, and ultimately burst into a supernova, among the universe's most forceful explosions. Depending on age and developmental stage, stars emit illumination in various wavelengths, from the bright blue of younger stars to the red of elder ones. Based on the historical stargazer Tommy, Betelgeuse exhibited a hue he intriguingly classified as ruddy. Despite this, early Chinese astronomers remarked that Betelgeuse appeared yellow, hinting that it may once have been a yellow supergiant. Massive stars swiftly burn through their hydrogen, leading to an early demise. Although their lifespans only 10 million years, there's no doubt that Betelgeuse is in its concluding phase. While our Sun still possesses more than 5 billion years of life, Betelgeuse is approaching its final moments, meaning it may one day erupt in a supernova. However, the precise schedule of this occurrence remains unknown. Betelgeuse experiences two cycles of brightening and fading, one occurring every 5 years and persisting for around 100 days. It is assumed that the swelling and shrinking of its outer layers during these rhythms induce alterations in its diameter and regular surface temperature. Considerable interest in Betelgeuse grew during its unpredictable behavior in 2019 and 2020, when its light faded dramatically before recovering briefly. Certain scientists have theorized that this peculiar activity could indicate the star is nearing its final transformation. Comprehensive analysis of Betelgeuse dates back to the 1st century BC. Yet, the origin of its dimming remains an absolute enigma. Betelgeuse has been observed moving through the interstellar environment at approximately 30 kilometers per second after being ejected from its birthplace in the Orion-OB1 association, which houses the stars of Orion's belt. The resulting bow shock extends beyond 4 light-years. Measuring the proximity of red supergiant stars like Betelgeuse is an infamously difficult task. in astrophysics, as various factors prevent accurate diameter estimates. Furthermore, since it is a pulsating star, Betelgeuse's size varies over time. This feature, along with the dimming of its outer edge, causes its observed glow to shift in color and lessen as we view it farther from its center. Additionally, the shell of material expelled by the star plays a critical role in light emission and absorption, also affecting how we interpret its brilliance. Directly contrasting views of Betelgeuse is challenging since its visible size changes with the wavelength observed. These measurements can vary by up to 35% based on the part of the light spectrum employed. In July 2009, the European Southern Observatory released visuals captured with a very large telescope VLT interferometer on its ground-based observatory, revealing a large plume of gas stretching up to 30 astronomical units from the star's surface. One of many mass ejections seen from Betelgeuse. This outflow matched the angular distance between the Sun and Neptune. At least 6 such events have been observed around Betelgeuse. These occurrences might reveal clues to the question of mass ejection in the concluding periods of massive stars, which are central to their destruction. The complex processes within Betelgeuse's extended upper layers remain perplexing, as does the exact method by which red supergiants eliminate their matter? Such stars are fundamental to the circulation of elements within galaxies, and due to progress in interferometry, astronomers are drawing closer to answers to these riddles. In 2019, scientists employing the Hubble Space Telescope and other observatories observed that Betelgeuse had blown off a vast part of its outer shell, triggering a massive surface mass ejection (SME). Although the Sun creates solar mass ejections, Betelgeuse's events were thousands of times more severe, with this episode flinging out material 400 billion times the mass of a regular solar eruption. This accounts for why Betelgeuse suffered a steep drop in luminosity in October 2019. By mid-February 2020, it had lost nearly 3 times its brightness, shifting from magnitude 0.5 to 1.7 by February 17th. In 2020, Betelgeuse's brightness had stayed largely consistent for more than a week. On the 5th, it looked like the dimming had stopped completely. However, the recent decreases in visible light were not connected to a likely core collapse, as no significant changes in infrared radiation had been registered on February 24, 2020. Feel free to share your thoughts in the comments section. If you liked this video, click the thumbs up icon and subscribe so you won't miss future content like this. When Betelgeuse ultimately detonates as a supernova, it will be among the most dramatic cosmic occurrences ever documented, even at a distance of 640 light-years. The blast will be so radiant that it may outshine the entire moon or even be seen during daylight hours for several weeks or maybe months. Experts estimate that the supernova will discharge more energy in mere seconds than our Sun will emit during its entire 10 billion year lifespan. The illumination from the explosion will speed through space and eventually reach Earth as a brilliant pinpoint of light unlike anything we've witnessed before. But rest assured, we're entirely safe. Although a supernova that near may sound threatening, Betelgeuse remains distant enough that the detonation will not harm Earth's biosphere or living beings. What it will do is present an extraordinary scientific event. As of the past few years, Betelgeuse has returned to normal brightness levels, but its irregular dimming patterns are still under intense observation. Scientists are leveraging equipment like the James Webb Space Telescope, the Hubble Space Telescope, and land-based interferometers such as the VLT and ALMA. They're tracking surface light fluctuations, patterns in convective activity, and persistent mass outflows that seem to reflect the star's instability. One well-supported theory is that Betelgeuse's great fading was caused by a massive cloud of starborn dust created during one such eruption, momentarily veiling the star's light from our standpoint. Understanding the mechanisms behind Betelgeuse could help astronomers interpret the life stages of massive stars, particularly those nearing a supernova. Such insights could help forecast similar phenomena in other galaxies, explain how chemical elements enrich the cosmos, and detail the formation and scattering of elements like iron and gold throughout space. Betelgeuse is effectively a ticking cosmic timepiece, and it's winding down slowly. It may explode tomorrow, next year, or in 100,000 years. However, whenever it does, it will present a galactic spectacle and a wealth of scientific data unmatched in modern times. Understanding the life and death of stars like Betelgeuse is not only a matter of academic curiosity. It plays a vital role in shaping our comprehension of the universe itself. Massive stars are the forges where heavy elements are created. When these stars reach the end of their life cycles and explode in supernova, they scatter these elements into space, enriching surrounding interstellar clouds with the building blocks for new stars, planets, or even life. Betelgeuse's impending supernova offers a rare opportunity to study such an event in relatively close proximity. Most supernova observed by modern science occur in distant galaxies, limiting the detail and data scientists can gather. But with Betelgeuse in our own Milky Way galaxy and relatively nearby in astronomical terms, astronomers could monitor every stage of the explosion and its aftermath with unprecedented clarity. This potential observation is particularly exciting for those studying neutrinos and gravitational waves. When a star collapses into a supernova, it doesn't just release visible light. It emits tremendous amounts of neutrinos and can produce detectable ripples in spacetime. If Betelgeuse were to go supernova, detectors such as LIGO, Virgo, and IceCube could capture this data, offering new insight into both stellar physics and the fundamental forces of the universe. Moreover, astronomers are paying close attention to Betelgeuse not just because of its possible death, but because of what it can teach us about stellar behavior in general. Red supergiant stars like Betelgeuse remain some of the least understood stages in stellar evolution. They are massive, volatile, and difficult to model accurately. Advances in space telescopes and high-resolution spectroscopy are helping to change that. But many questions remain unanswered, questions that Betelgeuse might soon help resolve. In the meantime, Betelgeuse continues to flicker, pulse, and surprise us. Its brightness may seem constant for now, but scientists remain on alert, ready to capture every fluctuation in the event of a supernova. The data gathered could revolutionize our understanding of how stars live and die. Until that moment arrives, be it tomorrow or millennia from now, Betelgeuse will remain a focus in the night sky and in the imagination of astronomers everywhere. It stands as both a celestial marvel and a cosmic countdown.